This video is going to look at how to solve exponential equations, and I want to go ahead and warn you that I'm going to show you probably 3 to 4 different ways how we can solve these equations, but I want you to be able to choose the one that works best for you. So if I get to a technique that's more confusing, you can just kind of skip over that and look at the other ones. So if you notice here, we're going to be using our one-to-one properties, where if we have a to the x equals a to the y, and if that's the case, then that means the exponents x must be equal to y. We're also going to look at how we can solve the equation using the inverse property, and that's going to occur when we have log base a of x. When we take the log here, we're trying to match up this base with this base because they're going to cancel out, and then your answer is simply going to be the exponent. Okay, and then also we're going to be using how we can rewrite our exponential form here, a to the y equals x. And recall I told you that you need to understand how we can rewrite this into logarithmic form, because here we have our exponent y is equal to the log base a of x. Okay, so let's go ahead and get started seeing how we can use each one of these different properties to solve our equations. So I'm going to start off with a basic exponential equation, 2 to the x equals 8. Now the very first step in solving an exponential equation is you want to isolate the term that has your variable as the exponent, such as we have here. 2 to the x is already by itself. So now we need to get rid of the 2 so that we can get up here to the exponent x. Alright, the first way I'm going to look at doing this is we have 2 to the x equals 8. The first technique I'm going to use is the one-to-one property, where we get the same base to a power equals the same base raised to a power. So here we have a base of 2 raised to the x power. Can we write 8 with a base of 2? We can certainly write this as 2 to the third power. 2 cubed equals 8. So now that we have the bases here are the same, 2 to the x and 2 cubed, then obviously the exponents must be equal, so therefore x is equal to 3. Okay? Now, the next technique I want to look at is, let's say that we have 2 to the x equals 8. And I want to look at simply rewriting this logarithm. So in other words, let's think of rewriting this using this technique here. So if we have a to the y equals x, we want to rewrite this in logarithmic form. Well, that means our exponent, our exponent here is x. That's going to be equal to log base a, so that's going to be log base 2 of 8. Okay, now we've already solved for x. Now all we have left to do is calculate what is the log base 2 of 8. Well, that's where we can use that change of base formula, and we can find the natural log of 8 divided by the natural log of 2. So again, that's simply using the change of base formula. So then you would simply go to your calculator, and we would type in the natural log of 8 divided by the natural log of 2. And once again, notice here we get the answer of 3. So that's the same thing we had before. All right, so now we're going to look at another technique. If we have 2 to the x equals 8, I want to look at how can we use this inverse property where we have log base a of a to the x. So here we're trying to cancel out this 2. Well, because this has a base of 2, we want to use that inverse property. So we're going to take log base 2 of 2 to the x equals, and again here I'm going to take log base 2 of the 8. So here we're using the inverse property, which is our log base 2. Now why do we use base 2? Well, we wanted to use base 2 because we had our base was 2 raised to the x power. Because now, based on this property, log base a of a to the x is simply equal to the exponent. When these two values match up, they're going to cancel and you're left with the exponent. So what's going to happen here is we're left with log base 2 of 2, so they're going to cancel, so we're left with the exponent x is equal to log base 2 of 8. And if you notice, that's the same position we had here in the previous technique. So now all we have left is to use the change of base, which would be the natural log of 8 divided by the natural log of 2. And of course, once again, we would get an answer of 3. All right, one last technique, and hopefully I'm not making this too confusing, but I want you to be able to choose the one that works for you. 2 to the x equals 8. One other technique is we can certainly just take, where here we use log base 2, we could take the natural log of both sides of the equation. Now, if I was to take the natural log, that means we're having a base of e. Well, the bases don't match up because natural log is base e and we have a base of 2 here. But remember when those other properties we had, what can we do with this exponent? Remember when we had the logarithm of a number raised to a power, we could pull this exponent out front. And that's what we can do here. If we pull the exponent out front, we would be left with x ln of 2 equals the natural log of 8. So we still accomplished what we wanted. We got the variable out of the exponent. So now it's x times the natural log of 2 equals the natural log of 8. So to get rid of the multiplication, we're simply going to divide by natural log of 2. So we have ln of 8 divided by ln of 2, and we know that is going to be equal to 3. So here we have 4 different ways that we can solve this particular equation. The first technique we looked at was simply matching up the bases. This will work as long as we can get the bases to match up. This first method will not always work. The second technique that we used here in red, this will work simply by rewriting from exponential to logarithmic form. And the third technique, I want you to realize that how this inverse logarithmic function works. If we have 2 to a power, if we want that 2 to cancel out, then we're just going to take log base 2. And the reason we're using that is because then the bases will cancel and you're simply left with the exponent x. And the last technique, as I want to show you, that we can actually just simply use the natural log, and using the other property with our exponent, we can simply pull the exponent out front, and that changes it then to multiplication, which we can solve by using division. So the one great thing about this last technique is once we divide, we can already put ln of 8 divided by ln of 2 in the calculator. We don't have to worry about the change of base formula like we did over here in this previous technique, where we ended up with log base 2 of 8, where we had to then go to the change of base. So really, any of these techniques that you prefer, just try to choose one, or you may want to actually rewind the video and watch this particular problem again and see if you can determine which one that you prefer to use. Now again, the first technique will not work in all cases. It's only going to work when you can match up the bases. All right, so here we have another example. 3 to the x equals 8. And if you notice here, there's no way that we can write 8 so that it has a base of 3. So the first technique I want to use here is, how do we simply rewrite this from exponential form to logarithmic form? Well, we know it's going to be the exponent is equal to log base 3, where our base here is 3, of 8. So there we've already solved for x. So now all we have to do is use the change of base formula, and that would be ln of 8 over the ln of 3. And if we take ln of 8 divided by ln of 3, ln of 8 divided by the natural log of 3, and I'm just going to round this to 1.89. So we get approximately 1.89. All right, if we look at using another technique, we could take the log of both sides, and I'm going to take log base 3 of 3 to the x equals log base 3 of 8. Now, once again, why did I use this log base 3? The reason I used log base 3 is because I wanted this number and this number to be the same, because now all of this is going to cancel out and I'll be left with x equals log base 3 of 8. So then we can use, once again, the change of base, which would be ln of 8 over the ln of 3, and we'll get the answer of approximately 1.89. And if we look at one final technique here, and that is taking the natural log of both sides. So if we take the natural log of 3 to the x equals the natural log of 8. Once again, this allows us to take this exponent of x and move it out front. So if we do that, we'll end up with x times the natural log of 3. And then because this is x times the natural log of 3, we can simply divide the natural log of 3 away. So we have x equals the natural log of 8 divided by the natural log of 3. And that's where we will end up with 1.89. Okay, once again, pick whatever technique works best for you. All right, this next example, this is going to be a little bit different. We have e to the x squared minus 3 equals e to the x minus 2. And here, notice we already have the bases are the same. So I'm going to use the one-to-one property because the bases are the same. We have e on the left and e on the right. Then we can simply take the exponents, x minus 3, and set it equal to the other exponent, x minus 2. So now all we have to do is solve the equation for x. And if you notice, we have an x squared. So that means we're going to solve a quadratic equation. And normally that means we're going to move everything to one side and set it equal to 0. So I'm going to subtract the x. So we get x squared minus x. And then I'm going to add 2. So a negative 3 plus 2 would be equal to a negative 1. And now we need to try to factor. Well, if we try to factor this, we're going to probably quickly find out that 1 times 1, there's no way that we're able to really factor this. So that means we're going to have to go and use the quadratic formula. So x equals negative b plus or minus the square root b squared minus 4ac all divided by 2a. So if we're going to plug into the formula here, we would have x equals, and let's see up here we may want to write, remember this is a coefficient of 1, so a is equal to 1, b is equal to a negative 1, it's negative 1x, so this is b value is a negative 1, and your c value is also a negative 1. So if we plug these values in for a, b, and c, we would have negative b, so that means we'd have a negative 1 plus or minus the square root of negative 1 squared minus 4 times a, which is 1, multiplied by c, which is a negative 1, and this is all over 2 times a, so that would be 2 times 1. And then this is where you could easily go to the calculator. We have a negative, negative, so that's going to be a positive 1 plus or minus the square root of, and negative 1 squared is 1. And watch your signs here. We have a negative 4 and a negative 1, so that's going to be a positive 4. So that's going to make it 1 plus 4, which is 5. And that's all over 2. So then you could simply go to the calculator and you would type in 1 plus the square root of 5 divided by 2. Now make sure that you put that at 1 plus the square root of 5 in parentheses divided by 2. And if you do so, you should end up with an answer of approximately 1.62. And let me make sure that you can do that. If we would go here, we would type in parentheses 1 plus the square root of 5. Okay. Now, it depends on your calculator. Let me go back. If you have a TI-83, you're probably going to end up with parentheses. Once you type the square root, you're going to get parentheses 5, close the parentheses. Okay, so that's if we're only taking the square root of the 5. But then I want to close the parentheses around 1 plus the square root of 5, okay? And then all of this, and that's why I have parentheses around the whole piece here, all of that is divided by the 2. So then when we hit enter, we get 1.62. A common mistake here is to leave out the parentheses, and if you leave out the parentheses here, the only thing that's going to be divided by the 2 is the square root of 5. Then it's going to add the 1, but we want to add the 1 and the square root of 5 first, then divide by 2, so that's why we have the parentheses. So therefore we get 1.62. And then if we subtract 1 minus the square root of 5, and I can show you a little shortcut here. If you were to hit second function and enter, that brings down the last entry, and we can certainly just move our cursor over to the addition and change it to a minus and hit enter, and we get a negative 0.62. So here in this case we end up with two possible answers, and that's because we have this quadratic equation. So that means here for this equation, x could be either equal to 1.62 or a negative 0.62. All right, one last example. 4 times 3 to the x equals 20. Once again here, the first thing we want to do is we want to isolate the part that is raised to a power. So we want to get 3 to the x by itself. So that means we want to get rid of the 4. So to get rid of the 4, we're multiplying so we can divide by 4. And if we divide by 4, we will end up with 3 to the x equals 20 divided by 4, which is 5. And now, how can we solve this? Well, we can't use the one technique because there's no way for us to write 5 as a base of 3. So we're not going to be able to use the one-to-one property. So we can certainly just rewrite the problem. And if we do that, once again, our exponent is x, and that's going to be equal to log base 3 of 5. And since we have rewritten the problem, all we have to do now is use the change of base, which we can use ln of 5 divided by the ln of 3. And if we put that into the calculator, ln of 5 divided by ln of 3, we get approximately 1.46. Okay, now the other technique that we could use here, if we have, once we get to this point right here, 3x equals 5, we could always take the log base 3 of both sides. So in other words, I could take log base 3 of 3 to the x equals log base 3 of 5. Now again, why did I choose the log base 3? Because we wanted these to match up, so therefore they cancel. We're left with x equals log base 3 of 5. And then once again, all we have to do is use the change of base, which is the ln of 5 over ln of 3, and we would get approximately 1.46. And then one last technique, if we get to the point of 3 to the x equals 5, and this is where we could certainly just take the natural log of both sides. And once again, I know the natural log does not have the same base, but we can use the other property of pulling this exponent out front, and therefore we end up with x times the natural log of 3, and once we change it to multiplication, we can divide the natural log of 3 away. So ln of 5 divided by the ln of 3, we end up with, once again, approximately 1.46. And let's see, maybe we'll have time for one more example. 4 times e to the 2x equals 16. Once again, we want to isolate the e to the 2x, so we're going to divide by the 4. So if we divide by 4, we're going to have e to the 2x equals 16 divided by 4, which is 4. Now here we could once again just simply rewrite this into logarithmic form. So we know we're going to have our exponent. Now notice the exponent here is 2x. So we're going to have 2x is equal to, now that would be log base e, or I'm just going to write the natural log of 4. Okay, so now all we have left is to divide the 2 away. So if we divide by 2, we would have x equals the natural log of 4 divided by 2. So then if you go to the calculator, we could type in the natural log of 4 and simply divide that by 2. And we could round this to say 0.69. So x is approximately 0.69. Now, one common mistake here is do not divide the 2 into 4. We cannot take 4 divided by 2 and make this the natural log of 2 because we're taking the natural log of 4 then dividing by 2. Okay, so be very careful and do not try to divide the 2 into the 4. And of course, the other option here, if we get to e to the 2x equals 4, we could certainly just take the natural log of both sides of the equation. And why would I choose to use the natural log? Well, the natural log is a base e which matches up, so what happens there is they're going to cancel out and we'll be left with the exponent 2x equals the natural log of 4. And once again, that means we would take and divide by 2 and we would end up with 0.69. All right, so once again, hopefully this wasn't too confusing with going through several different examples or techniques for each problem, but I want you to be able to choose which one works best for you. So realize again, we have this one-to-one property, the inverse property, and we can use rewriting from exponential form to logarithmic form. And also the other technique is I showed you where you could certainly just take the natural log of both sides and then pull the exponent out front. So again, you may have to go back and watch this video a couple more times and find out which method is going to work best for you.